Hello, this is Jyoti Vashisht and I have implemented the concept of operator overloading. So in this I have created a class that is matrix and it has a data member vals that is a two-dimensional array, and then there is this parameterized constructor which takes in as the parameter an integer array and then assigns that the value or the elements of that array into the elements of this val's data member. And then there is another constructor with no parameters and it does nothing. So coming on to member functions, I see the matrix, I see the function transpose which has a return type of matrix. So for that I have created an object of matrix type, and then I just perform the transpose operation by doing this. That is, I interchange the values of the columns and the rows. I mean, I of j, the vals I of j becomes vals j comma I. So then I just return the value, return the object ce, and then there is this function void enter which just gets the value from the user and stores it into the vals variable, vals data member as we see. And this is done by using the function in.parse. It converts the string object, the string value which has been entered by the user into the integer type and then stores it in vals data member accordingly by using two for loops as you see. And then for implicit type of conversion, I've used this concept so as to just convert the matrix data type into integers. So as we see, this is, I have to convert the corresponding parameter into this type and and as we see, I just return d dot vals, that is the as we know that vals is a 2D array of 2D array of the matrix D. For explicit type of conversion, I just use this syntax, that is public static explicit operator matrix. So in this case I wanted to convert an integer array into a type known as matrix type. So for that I just create an object of matrix type and then pass on the value a over here is an array. So for that, the constructor which will be called would be the parameterized constructor as we saw over here, and then the values will be initialized accordingly. That is, the elements of this array would be copied into vals. So after that, now when we get all the values and all the operation has been done by the constructor, I return the corresponding object and it will be processed accordingly in the main function when I use it. So coming on to the operator overloading, firstly I have overloaded the operator plus. For that I pass on two parameters. There are two parameters of type matrix, and then I have to create another matrix type object so that I can store the values after adding the elements of these two and then finally return it as we can see. So here the return type is matrix and the syntax is public static matrix which means the return type operator and then the corresponding operator. So now when I overload the minus operator, as we see, I just subtract the values of a dot vals of ij from b dot vals of ij and then correspondingly return the same object, that is c. So now when I want to overload the operator star, that is, it represents multiplication, I perform the multiplication operation on the two matrix objects and then store the value into another newly created matrix object as we saw c and then return c as follows. So now when I see this display function just displays the values of the data member vals and that's all it does. So now in case if we want to overload the operators like equal to, this equality operator, we have to implement this not equal to also, plus we have to override equals and get hash code for the go to work perfectly fine. So here when I just overload this operator, the return type is bool, and firstly I've created a variable of type bool and I have set it to false. So in case if the values of this object matrix A and the matrix B object does not matches, it will immediately return false, or else it will set y to true. So in any case, if it is not equal, it will return false, or else it will return true. So now I do the opposite, that is I have used the not operator to return that not equal to does the opposite operation of equal equal. So now when I override the equals object, equals function, I do the same thing, that is I get the parameter that is of types system.object. As we know, object is the base class of all the objects of the C hash family, and if the object is null, I return false, or else I just move on and check if the value if the value of the object which has called this function and the object which was passed as the parameter, as we see here, I have converted into the matrix type by using the as operator. I return the value true or false accordingly. If it matches, I set answer to true, or else I set answer to false. In the end, I just return the value of answer. So now this is the main class. As we see in the main class, um, as we see, I just provide the user with a function of the following. As we see, matrix addition, subtraction, multiplication, equality, checking the equality of two matrices, and then performing the transpose function. So now for that I have created three objects, that is matrix M1, matrix M2, matrix M3. So let's say I want to store the user input into these two objects, so I have to call the function enter so as to get the elements into vals. Vals, as we recall, is a data member, a multi-dimensional data member. So now when I add the values of M1 and M2, I store it in M3 and then display it and then return the operation performed on adding these two matrices would return an object of type matrix, and then I call the function display to display the values of that object itself. So the same concept has been applied for subtracting and multiplying also. So now moving on for implicit and explicit type of conversion, I create two kinds of object of the same type matrix, and then for that M1 equal M2. If it returns true, I'll just call the I will just display on the console these matrices are equal, else I'll display these matrices are not equal. This was operator overloading. Now we'll see the implicit and explicit conversion. For that I have used an array, integer array of size 9, and then I get the elements of this array from the user and store it in SA accordingly. That is by using the for loop itself. And now I create a matrix object, and then I try to convert SA into matrix. So now this is working perfectly fine because I have used the I have implemented the concept of explicit conversion above, as we saw, and then similarly I use the concept of this is implicit conversion, as we see by calling the me.transpose, which returns a variable. Me.transpose just alters the value of the vals variable and performs the transpose, and this itself is returned into an two-dimensional array without any error because I have already implemented the concept of implicit conversion. So now I just see the output of the transpose function, and that's all I have done. So let's check if everything is working fine. So I perform matrix addition first. It asks me the first values of the first matrix. So now the second matrix, let's say I'll enter all zeros in the second matrix. So yeah, this is the final output. Yeah, it's perfectly fine. So now let's say I want to subtract. So as we know, I'll just enter the values as 1 2 1 2. So now if I do the following, if I enter the values at 3, we can enter anything. I get the following output. Yeah, it's perfectly fine because I subtract the values of the second matrix, I mean the first matrix from the second. So 3 minus 1 is 2, and yeah, it's perfectly fine. 3 minus 21 is minus 18. Yeah. So now going on to matrix multiplication, I get the values of the first matrix. Yeah, now the second matrix, I get the following answer. Yeah, it's perfectly fine. So now let's check whether two matrices are equal or not. So now for that, I just enter the first matrix and the second matrix. Let me say it's the same matrix. Yeah, these matrices are equal. So as we see, the whole concept is working fine. So now for performing transpose, as we saw, I have used the concept of implicit and explicit conversion. So let's see whether it is working perfectly or not. So I enter the values of the array. So yeah, so the original matrix would have been 1 2 3 4 5 6 7 8 9, but instead the transpose of the matrix has been represented by 1 4 7 2 5 8 3 6 9, which is perfectly correct answer. So thank you.